So in this tutorial, we're going to cover creating charts and graphs based off of data that you have accumulated for evaluation purposes. One of the benefits of having a graph is to be able to look for certain trends in the chart. But one thing that's very important is being able to understand how to do the interpretation once you spot trends. So let's go ahead and take our data here that you recall from our previous video, and let's use this to create a graph in order to do that analysis. So what I'm going to do is if I highlighted all my data and I went to insert a chart, I'm just going to choose randomly. I just want to highlight real quick the perils of just randomly going in there. You'll see that the graph that you get is, well, it's messy, but that's okay. If you wanted to, and sometimes people like to do this where you just copy and paste the chart once you've worked with it, but we're going to make life easier, so let's get rid of this and start simple. We're going to make a simple position versus time plot. To do that, we go up to Insert, we roll over to Chart, and you'll see Insert has all kinds of great stuff. Some of them better for use here in Excel, some of them better for use in Word, and again, similar thing is true for your Google Sheets, Google Docs, and others, spreadsheet and word processing software. So we're going to come over to charts. There are a few different options. There are bar charts and pie charts, histograms, and so forth for various purposes. Again, Excel has been built for industry, and science gets to play along. But what we're interested in is a very straightforward way of graphing the data, which is through using a scatter plot. So you click on this down. You have a few different options. Your options include data points only. Data points that are connected by a smooth rounded line, which can be problematic. You can have them with the data points or without. You can have them connected by a not smooth, a point-to-point straight line, and then without the data points. The idea when you do your analysis, you want, if you're going to have them connected, you want to have them connected by a straight line, because the rounded lines suggest data that you don't have scientific reason to anticipate. So it is scientifically inappropriate to use the rounded lines, the smooth lines. So use the jagged lines if you need to have lines there. Sometimes you don't need those lines. Sometimes they can help draw the eye in the direction you want. So for the moment, we're going to go ahead and use this with straight lines and markers. And let's make this larger. You just grab the corner and just click and drag this, just as you might in other cases. But you notice that there's some problems with this graph right here. You notice that we don't know anything about what this graph is showing. It's a nice smooth line. What's this big jump here? That's interesting. But it's got a title, but there's no axes, there's no units, there's no information here that tell us anything that we can draw conclusions from. So there's a few ways to do this. One, you can come up to the plus line here. So you come up here, you click on this, and you'll notice that there are some options. You see some check marks are missing, and we can click on these check marks, but there is actually a bit of a shortcut way. So let's close this one up. You'll notice that you are now in a Chart Tools special submenu that's come up for this chart. You have Design, you have Format. Right now we're in the Design area, so let's go over here. You can add individual chart elements. This is the same menu as the plus menu on the chart itself, but we can go to Quick Layout, and this is a fun one because you have some preset forms, and I'm going to mouse over them, and as you mouse over them you can see some different ones, and over time as you get more familiar with Excel you'll find the ones that are pretty convenient. I'm going to choose this one right here for now, and there may be some cases later on down the road that you may find this one, but this right here, this first one, is our best option. When we click on it, you'll notice now we have an axis title that we can fill in there. On both axes we have a legend that we can use if you want to use a legend. So we have some options. So let's just click on the menu. Let's go back home to the home, and I'm going to make the things a little bit larger to make it easier to read. So I've boosted them up to size font 11. That should be fairly close to the font size that you'll have in your Word document. I like to fill the space. We have space available. Let's fill it with data. Let's make sure that we can extract all the information we can out of this. So now, remember, this is position versus time, Y versus X. We want to always kind of keep that point there. Position versus time, Y versus X. So Y is going to be, if you double click on it or multiple click on it, you can type position. Don't forget units. It's always important to have units on there. If you don't have the units on there, your graph still struggles with communicating the information you want to convey. We'll come down to the axis title horizontally. Time is most often your horizontal time, and again in the units of seconds. Okay, good. We're looking better. And one thing that you can do also is, again, you can boost the font size of your, and maybe even bold it to make it stand out a little more clear. So these are all, personal choices. You don't have to do these minor changes, but you do need to have the axis labels in place. You'll notice along the way that a tile is on the side here is opened up, and you can make some changes here. So one thing you'll notice is that this data stops at about 9 seconds, and the chart goes all the way to 10 seconds. So we can change that. If you click on one of the numbers on a given axis, you'll notice on the right hand side you've now got some options available. What we're looking for is these bars here. This gives us our control over the axis. So if we click on the first option there, axis options, and go down, you'll notice the minimum is 0 and the maximum is 10. Well, we want to use up that space, so let's make that 9 instead of 10. And you can just hit tab in there, and you'll see that now we've respaced the space, graph space. We can also do the same thing vertically. If you click on the vertical numbers, it changes. Now this is for the vertical axis, and you can go again. We notice that 5.1. These are some options, and sometimes it takes a little bit of playing with. I'll change this back to 0 because it automatically reset. And so now we've more or less filled the space. So sometimes when you're analyzing your data, you've got data all over the place, and certain physics are happening in certain places in the data. This is position versus time, and if you've already taken the lectures on this, you'll know that a straight line for a position versus time means a constant velocity. But a changing line, a curved line in position versus time, corresponds to acceleration. And so if I come out here and I just go up to insert, and I want to insert a shape, this is just demonstration, just so you can see. You'll find that this region is mostly, let's make that shape fill, no fill. Let's make the outline heavier. You'll find that this region is where your data looks most straight. And when you add in a second shape to highlight that in this region, you'll notice that the second region is curving, and that must correspond to acceleration. So the idea here is, okay, so we want to maybe do a fit. We want to do a fit of this little bit. Again, your data is going to come to you. It's not going to be perfect. So what we need to do is we need to add a copy of the data to this region that we have highlighted in blue. That way we can do a fit of that region and extract a formula. To do that, we highlight the plot, come up to Chart Tools, and you see under Design there's Select Data. You can also right-click on your table and see Select Data. So we can do either one of those options. So I'm going to click on Select Data, and you notice that our box kind of goes from about a little after 1 second to about 4 seconds. So we're going to add a data chart, select the range. The series name we're just going to call constant speed. And we click on this, and we click on the time starting after about 1 second. So I'm going to pick about 1.2, and I'm just going to scroll down until I get to about 4 seconds. Now it's important that you grab the same number of cells for your Y data as you took for your X data. So we're going to click on this, and we're going to go again from the Y data that corresponds to 1.2 seconds, and slide down, click down, and you notice that your B15 to B43, C15 to C43, these correspond, and we click OK. And if you look on your data, now there's an orange tab that shows constant speed. Click OK, and you see that you have constant speed has now been added to this. This is a second data set. it's a subset of your original data, but this data now is all by itself, and we can do a real quick analysis on that. So let's go ahead and remove the boxes for now. That was just for demonstration. Sometimes students do exactly what I do in these videos and make sure that you are getting the point. Those are just for demonstration purposes. Don't put boxes on your charts unless you feel it is diagnostically prudent. Just make sure that you recognize we were trying to highlight this section. Okay, so you see now that we have these orange data points. So let me right click on the data points, and you see that you can do add a trend line. We can click on that add a trend line, and there are a few different options for it: exponential, linear, logarithmic, and so on and so forth. This looks like a straight line to my eyes, at least in the simple sense. So we're going to just stick with that and leave it as linear. And this means that it's going to fit a line to this that matches y equals mx plus b format. Now you can kind of see it's there, but it's not necessarily obvious. So one thing you can do is you can forecast forward and backward that line so that we can kind of see it extend beyond the data. So let's just put it in there. You'll notice we have 4, so we're going to forecast forward, say about 2.0 seconds. And since we only have about 1 second to work with on the other end, we're just going to put 1.0. You can go 1.2 seconds, but then it starts to play with your chart's automatic format space. Now, what Excel has done is it has asked each of these data points mathematically, how far are you from the y equals mx plus b that I think you are? And then it does this over and over again in these multiple iterations until it finally gets to a point where the changes as it changes the m and the b of your y equals mx plus b. And it says this is the best fit. So let's go ahead and display the equation on the chart, second to last option. And we want to see how good that fit is over that data. So we'll click on display r squared. Anytime that you have data that you are testing to a formula, you want to have your graph to show an equation in r squared. You will lose points if these are not on there. So always make sure that you check your lab manual to make sure that you are including all the points for a chart that are required. But you'll notice that I can move this around. This is y equals 0.6331x plus 0.1191. Excel doesn't know what you've labeled your axes, so it will give you y equals mx plus b format. It is your job in your lab report to record the appropriate function, which in this case would be, and I'll give you an example down below, x as a function of t equals 0.6321 time plus 0.1191. This is what your formula should look like when you type it into your equation editor in Microsoft Word or whatever the equivalent is in your word processing document. That's basically it. There is one other little trick that I'm going to show you, just especially when you're working with data that you're going to look at multiple types of data for the same range of data. So we've done all this work with this one chart. You can go back and redo all this process again, or you can copy, Control C, come right down below, and Control V. And you say, well, why do we do that? Well, the reason is because we've done position versus time. Let's look at velocity versus time. So when I right click on this, I'm going to select the data. I'm going to come down to run position 3. But instead of run position 3, you see it's highlighted that. We're going to highlight run 3 velocity. And instead of being, so the x values are still time, we don't want to change that. So we're going to change it now from C. You can just type in here, make that a D, delete the C. Make that a D, delete the C, and click OK. Click OK, and now your data looks kind of funny. This is fairly easy to fix. Again, you click on your vertical axis, go over to your bars, click on the axis options, and just reset. It'll automatically resize the vertical in the way that it is. And now you can see how the velocity has gone versus time. We want to make the same analysis with the segment in there, so we're going to change that accordingly. Go into constant speed, edit, again, change C to D. Click OK. Click OK again, and now you see we still have our fit function on here with a very, very, very almost zero slope over that same range, and you can extract data from there. We change the, it is important to change the label meters per second so that it all matches. But now you don't have to go back and reformat again and try and get them to match. You've already copied the formatting. You just now adjust it for analysis for this one. That concludes this tutorial. If you have any questions, always make sure you can talk to any one of us, your TAs, myself, and if you feel like there's anything else that you think I can add to these tutorials, by all means, please let me know. I'm happy to make them for you. And that does it for this tutorial. You guys have good luck in analyzing your data. We'll see you in the laboratory. Boom, boom, boom. Boom, 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 boom.